You're listening to the Australian Water Association podcast series. My name is Jo Taranto, and joining me is Dilusha Weeraddana, a researcher at Data 61 at CSIRO, and Livia Bonazzi, the General Manager for Strategy at Western Water. Welcome, guys.
Thank you, Jo. Thanks for having us.
We're talking about using machine learning to prevent water main breaks. Livia, do you want to talk a little bit about Western Water and what you do and who you serve in your customer base?
Yes, Western Water is a water utility in the northwest of Melbourne, over a surface area of about 3,000 kilometres. Our population is set to double in the next 15 years, so we're grappling with the challenges of how to service this growing customer base with the most efficient and cost-effective solutions.
And Dilusha, you're a researcher at CSIRO. What is it that you do with Data 61?
So Data 61 is the one business unit which comes under CSIRO. So CSIRO is one of maybe the most leading research organization in Australia. So in Data 61, we mostly, in my group, we deal with data, lots of data, and understand what's going beneath this data and try to make predictions to help assess management in our group. That's what we mainly do.
Livia, you've come to identify that there were some process improvements, or there were some improvements that could be made at a strategic level. Can you tell us a little bit about how you felt that the pipe failures that you were experiencing at Western Water could be improved with the help of Dilusha and her team?
Yes, so a few years ago I was new to the water sector. My background is local government and asset management. And just coming in, I realised that across the whole country we have about 44,000 water main failures a year. The challenge is that it's an underground asset. It's not cost effective, and it's a challenge to conduct visual inspections. So we were undergoing a process of introducing a data analytics strategy in the organisation, and I was really thinking from a customer service perspective, each service interruption creates a lot of challenges for our customers and inconvenience. It's also an extra cost for the emergency repairs, not to mention the water losses. So from a Western Water perspective, I was wondering what would be good to have under the Christmas tree, a model that actually assists us to prioritise the renewals program for water mains that detects the moment just before failure. It was at this very conference 3 years ago, Ozwater in Melbourne, that I stumbled across the Data 61 booth, and they were exhibiting some sort of work that they did in this area for other major water utilities outside of Victoria. And it was just serendipitous that we were aligned in our thinking. And so a project has come up from that. It took a while to set up, but it appeared that they could give us the answer in designing a machine learning predictive analytic tool that uses historical failure data and the brain power from CSIRO to give us a 20-year forecast down to the very pipeline asset level with a likelihood of failure that could assist us in prioritising our water mains renewal program.
Dilusha, you've obviously come to this project with a background in machine learning and data analytics. For the amateurs in the room, me, can you tell us a little bit about how you do what you do using this historical data and obviously all the information that's given to you? How do you therefore try and predict what might happen in the future?
Yeah, interesting question. So Western Water approached us, and with their data, network data, and also historical failure records. Usually what we do in this kind of project is we use machine learning techniques. People are mostly familiar with the term called artificial intelligence. So I will use that term, AI. So in the AI, mostly for people it's a black box, but we try to understand what's going inside that black box, and we try to develop algorithms inside this black box. So that's what we do. So what we usually do is when we got this large set of bulky data, we clean that data first, and then we apply machine learning algorithms to train our model. It's like a system, so that when you feed with the data or information, it train or learn the system. And then when we give unseen data, so it tries to predict from the learned past history and predict the future. So that's what basically this black box does. So it trains itself using the historical data and then predicts the future. That's, I think, without going into detail, that's what the artificial intelligence does. Kind of do the predictions, or it does classification, it does many things. So, but in our case, it's mostly about forecasting and predictions using what we have.
And do you find that something like a water main behaves in a predictable way? I mean,
no, it is not.
Good,
Yeah.
good.
Yeah, and in this case, we provided fairly likelihood for each pipe. It's not for only a suburbs, which consists of many pipes, but this is for each pipe in detail. So it's not a easy task, because pipe failures are not very common as well. So one pipe, and also these failures does not only depend on age. So there are some new pipes which may fail than the older pipes. Some older pipes are more robust. So in that case, it's a bit tough to do it manually. So that's why we rely on these machine learning algorithms.
So what have been some of the outcomes then for you, Livia, in terms of the project?
The projections of the model show that by 2030, our bursts will increase by 22% and the fittings failures will increase by 26%. So that's given us some robust information to deal with our renewals program. From a model perspective, we own the IP, and so we can adapt it and apply it to other asset types, for example, sewer mains. But we can apply the methodology to also model THMs in our water network.
I guess for you, Dilusha, and yourself, Livia, how important is it for the industry to collaborate? And I'm assuming here that data is more robust the more data you have, right?
Yes,
so
exactly.
the outcomes are. So what would you like to see from the industry?
Yeah, so first of all, I must say, so this particular process of constructing this machine learning model, it's not just an agile process which goes like sequentially. Like time to time, we got back to Western Water and got their feedback to improve our model, and they have provided more data which actually improved our model. So it's all about having more data, but not only more data, more quality data as well. So we can apply this model to specifically to other water utilities. We have been doing this for Western Water and Unity Water as well. Not only not only drinking water, but for sewer networks as well. So yes, this same model can be applied to other industry applications that we are working on those projects. It is possible, yeah.
We've been joined by Dilusha Weeraddana of Data 61 at CSIRO and Livia Bonazzi, the General Manager for Strategy at Western Water. Thanks so much for your time.
Thank you so much, Jo.
Thank you, Jo.